We're now going to move on to Emeritus Professor Mark Howden, a dear friend and very important person at the moment as Vice Chair of the Intergovernmental Panel on Climate Change, because I guess you've been busy responding to everything going on, Mark. So we're very thrilled that you could take time out of your busy schedule to share here, because I think your reflections on adaptation and how we bring this into net zero precincts is really important. So I'll hand over to you, and we'd love to have you. Thank you.
Well, thanks, Peter, and thanks for the opportunity to speak here today. And yes, it has been running hot with the media, with you know, national climate risk assessments, national adaptation plan, climate targets, and now typhoon Ragasa. So I was just picking up a call as I was multitasking on this on this one. Sorry about that. Anyway, what I'm going to do today just is talk a little bit about climate adaptation, because what we see oftentimes is a focus on where we're dealing with climate change in terms of the built environment. Often it's in relation to greenhouse gas emissions and life cycle assessments of those emissions and similar things. And that's really important, because we have to push down on those emissions because they're the thing that's driving those climate changes. But what I'll be talking about is, given that we're already experiencing change and that it's likely to continue in the future, what might be some of the things we can think about to manage that change in relation to net zero precincts. So I'll just share a screen, and hopefully that's coming up as a full screen for you, Peter.
At the moment, I can see you.
Hasn't come up?
It said you were going to share, but then it's gone back to you.
Oh, okay. Right, yeah, I'll have to try that again.
Yeah. Says Mark Howden has started screen sharing. Yep, now we can see it, but it's not in full screen mode.
Okay, now it's in presentation mode, hopefully.
No. Yes, perfect.
Perfect. Everything's a little bit laggy from this side of the continent. Sorry.
We are the Wild West, Mark.
Indeed. So, so I guess and I'll go quickly through these slides. But the first thing I'd point out is that our greenhouse gas emissions, in spite of various goals that Australia might be setting, our greenhouse emissions across the globe keep on going up. And this is a graph of carbon dioxide emissions from fossil fuel use, industrial processes, cement manufacture, that sort of thing. And you can see that they've gone up from 20 and a bit billion tonnes a year. And last year they were getting towards 40 billion tonnes. And then there's another 4 or so billion tonnes from land clearing and another 10 from other greenhouse gases. So we're producing a huge amount of greenhouse gases, and they're building up in the atmosphere, and that's generating really significant change. And we can see that those greenhouse gases, they've occasionally had a bit of a dip, like where we had COVID or where we had the global financial crisis. But on average, pretty much every year breaks the previous record, held by the previous year. And that's the pattern we've seen. And it's likely this year we'll break the previous record as well. So and unfortunately, in spite of the fact that China is looking like it's over the top at the peak, with the US pulling out and ramping up and drill baby drilling, it's likely to push emissions up again. And that means that the carbon dioxide concentrations of the atmosphere are at record levels, and they're going up really fast, and they're well above 1.5 degree consistent pathways. And it's not just carbon dioxide, but it's other greenhouse gases like methane, which is now triple pre-industrial concentration. So we're mucking around with the atmosphere and the temperature controls of the earth in a big way. And just to sort of give you a bit of a feel, if we were to keep to 1.5 degrees, which is what we said we'd do under the Paris Agreement, we'd have to go on a trajectory like this dashed one. And that doesn't end at the bottom of this graph, it actually continues well down below your screen at the moment. And so at the moment, I'd be saying we have no chance of getting onto that trajectory, and I'll talk about that in a second. Given that we've known for 200 years that if we actually put greenhouse gases in the atmosphere, we'd warm the Earth, it's not surprising that we've actually seen this warming trend. This is a World Meteorological Organization graph, and it shows how we're going up in terms of temperature very quickly. And last year was the first year above 1.5 degrees, and it was 1.55 above pre-industrial. And on a trend basis, we're going to meet 1.5 degrees probably next year. And so, things are changing pretty quickly. And Australia has a similar trend in terms of temperatures to the global. So we're no different, as you'd expect. What perhaps people don't expect is just how quickly that's influencing extreme temperatures. And extreme temperatures are the things that drive energy demand and also impact on supply in net zero precincts and other systems. This is a graph from the Copernicus Climate Group, and it shows the number of days in a given year that are in different temperature categories. So between 1 and 1.25 degrees above pre-industrial, 1.25 and 1.5, or more than 1.5 degrees, the increasing darkness of the things, the bars. If you go back to 1990, you can see that very few days were even above 1 degree. If you fast forward to 2024, 3/4 of the days were above 1.5 degrees, and all days of the year were above 1.25. And so, those sorts of extreme changes are happening very, very quickly, and quite concerning, because there's more and more evidence that impacts on systems that we value. It hurts people, it hurts our environment. What do scientists expect to happen out into the future, given our understanding of both the emission side of things and the atmospheric dynamics and how that translates to temperature? And the answer is not great. Is that in a survey last year by The Guardian, nearly 80% of scientists foresaw that we were likely to exceed 2.5 degrees. And almost half said we were likely to exceed 3 degrees. Only a very small handful said we keep to within cooey of 1.5. 3/4 of those scientists surveyed said that the problem was a lack of political will, and we saw some of those institutional barriers that Dave was talking about, largely because of lack of political will to change. And there's a whole stack of stuff about vested corporate interests as well. And of course, young people and females also were more pessimistic. Now, why should we think climate is going to impact on net zero precincts? It's because climate impacts on energy systems generally in all sorts of different ways. So, for example, if you're relying on hydropower, that in Southern Australia and similar environments across the world is becoming more fraught. Rainfall is going down, evaporation is going up, hydropower is less available and more variable. If you're running a big coal-fired power station or nuclear power station, you need to keep that cool. You use huge amounts of water, and that, if you're going into a drying environment or a hotter environment, makes that more problematic. So, for example, 2 summers ago, half of France's nuclear power fleet closed down because either they couldn't get enough water or the water they released was too hot for environmental regulations. If we're looking at solar photovoltaics, there are actually significant reductions in output as temperature goes up. So on a very hot day, you get markedly lower output, so in the range of 10%, but it depends on the panel type and the location and cooling systems as well. And of course, demand goes up as temperature goes up, and what we're seeing across the globe is air conditioning penetration is way, way higher, going up incredibly fast, and it's becoming incredibly important in a range of different energy systems. So projections, for example, for India is that something like half of their electricity will be just chewed up by air conditioning alone, a decade or so out. And we're seeing, of course, less demand for heating in many places as well. So we can say, climate and energy generally, net zero precincts is very strongly linked in that way. Um, if we're thinking about climate and net zero precincts, we need to think about what the goals are that we're trying to achieve. So as per the primer, I said, and this is not exhaustive, but some of the goals we might be thinking about is ensuring that we have safe and secure systems, net zero precincts, that they're actually supporting people in terms of health and well-being goals, and also they're comfortable, that they are efficient and stable in a changing environment, the ups and downs of water supply, electricity supply, etc., that they look good, and because that enhances your capital value, as well as being linked to some of the previous items, and possibly things like enhancing biodiversity. So we like to see the parakeets in the trees and the black cockatoos and all those sorts of things in our suburbs and in our industrial precincts where they're well designed. There's a whole series of possible adaptations that we can put in place, and I haven't done justice to that in this slide, but we can improve siting and orientation of our buildings, to deal with a hotter and more variable and more problematic climate. We can design and construct our buildings much more effectively than we historically have. So, for example, much better insulation, much better air tightness. So we're moving to the sort of passive house type ideas, which can massively reduce your energy consumption, both in summer and in winter, and hence the energy that you need to produce to keep comfortable temperatures. You can also get, if you're going down that sort of more tight building envelope with mechanical heat exchangers, you can just shove on a HEPA filter and you've got a smoke-free environment inside. So it's a healthier environment inside than outside in smoky conditions. And of course, we can design buildings that are much more resistant to storm damage than in the past. So, for example, in tropical Australia, where you have to build buildings to a higher wind speed standard. You can do vegetation design and management, so urban forests is part of that, but just generally siting and using vegetation appropriately can significantly reduce energy demand, and as well as encouraging active travel and various other benefits in net zero precincts. And of course, water system design and management, so capturing, storage, infiltration are all really important in terms of managing the environment, not just to have a nice green environment, but also to reduce damage in extreme events, which are becoming increasingly more problematic. And of course, you can put that previous slide and this one together in terms of some sort of matrix where you're looking at the intersections of possible adaptations and possible goals. So you identify, where in that matrix you need to focus, and then just simply take a systematic approach to dealing with climate change adaptation. So you establish what your goals are in your net zero precinct, understand something about your climate change impacts that are coming down the track, thinking and evaluating your adaptation options and their co-benefits in terms of, say, energy usage or capital value, understanding the trade-offs between some of the other goals. So Bill Lilly will be talking about multi-objective functions, which is fundamentally about trade-offs, and then learning from that analysis so you can iterate and actually end up with the system that you want. So I'll just leave that there, but happy to answer any questions either before or after the breakout groups. And I'll just finish my sharing.
Thank you, Mark. Pretty sobering when you look at those numbers, which I know you've been dealing with for many years and just doesn't seem to be getting better, which is also really quite worrisome. I was in Singapore last week with Twinem, who are in sort of in investment philanthropy, And they're really looking to India and looking for innovation around HVAC because they see it as being so important. What was interesting for me, though, there was also all the green of Singapore. You know, we've still got such a long way to go here, and even in WA at the moment for the sort of greening and what that can do as part of it. So it's really important to sort of hear those views and think about how I remember we talked about mid-action for climate change back in the day, a long time ago. How do we bring those two together? I might just ask, has anyone got any questions for Mark before we go to the breakout rooms, thinking about adaptation and that? Is that Dave putting his finger up, wanting to raise his hand? Am I guessing there, looking at your expression, Dave? Or not? Might want to unmute.
Yeah, thanks, Mark, for that. Just two general questions. Have we actually done any modelling on, or are you aware of any modelling around Australia on impacts, like in terms of geographical area, down to sort of 10K by 10K? Do we sort of know what impacts we're looking at? Because I'm wondering whether or not, bringing those to life in terms of your patch, how it's going to change, may be helpful in changing the minds of decision makers.
Yes, thanks, Dave. There's plenty of information available. It's not necessarily you don't actually have to go down to 1K or 10K scales to get a handle on what those impacts are going to be, because many of them are regionally consistent and uniform. So, for example, in Southwest Australia, you're actually a poster child for reduced rainfall across the globe. So it's probably one of the best examples, or worst examples, of how climate change can impact on rainfall, and that will apply, regardless of minor variations in geography. And so there's plenty of information, and some of that's in IPCC reports. So there's a whole chapter on Australia and New Zealand, and that summarises that. But you can get information, in copious amounts if you want.
Okay, good, thanks.
Bill, you've got your hand up. If anyone else has a question, please use your raise hand. Thanks, Bill.
Yeah. I guess another just more general comment, but it's interesting seeing the stats there on the young and females being more pessimistic. Just reflecting on what that means, I think in the way that we're looking at this as broader education processes. Many of us that are older, that have been through a number of these political cycles, and probably have more reason to be pessimistic. So it is interesting to just see that and reflect on it.
I think the logic there is actually pretty simple, is that young people are the ones who are going to be living through the worst of climate change. And that's why they're more pessimistic than older people, who probably are saying, well, I'm going to be gone before it really hits us. And so I think that's the fundamental thing there. When you actually look at studies which have assessed how bad it is going to be for a child who's born now versus their grandparents, it's actually really quite horrifying. So a simple number is a child born now will suffer 3 to 4 times as many extreme climate events as their grandparents did in their lifetime. So instead of being something you experience a couple of times in your life, it'll become something you experience every decade and have to recover from. And that's why it's really important to start to factor in those climate disruptions, increased storm strength, etc., into our design.
Okay, I'm going to jump ahead of you, Dave, because Amy's trying to ask a question. Amy, over to you.
Absolutely.
Sorry, I'm obviously not tech savvy, so I can't find it. Can't find my hand up button. But
under the React. Okay, go.
Thank you. Thanks, Mark, for that. But I'm really interested when I'm, interested in the climate adaptation space in terms of energy. What I usually think of and go to first is, in an extreme weather event, like the disruption to our energy services. But I was really interested to hear and think more about the inefficiencies or dangers to the physical infrastructure itself and I was thinking, are there people working on some of those solutions around climate adapted renewable energy infrastructure like solar PV that works more efficiently on hot days and sort of safety of batteries in extreme weather events?
Yeah, there's plenty of work, and it comes in different formats. So, for example, you can get solar panels that have sort of both produce electricity and hot water, and so it basically it removes the physical heat from the system, and so that they're in a better operating environment. You can site your panels so that they have better circulation and ventilation, so that they cool down. Or if you're, agrivoltaics, where you're putting panels, in amidst a pasture or a vineyard, that tends to keep them a lot cooler as well. So they're in a better, more optimal temperature range. And different panels have different coefficients of loss as well. So you can select panels that generate more effective amounts of electricity. So rather than having that same degree of heat loss.
Thank you.
Okay, Dave, back to you, and then Hugh, and then we might go to the breakout rooms. Dave.
Yeah, Mark, I was just curious, obviously, to try and get onto an optimistic footing, which is pretty tricky in this space. Are there any big ticket items that or levers that we could pull that will make a radical difference? I mean, I was just trying to think, if you're trying to bend that curve, if you were to pick 3 things that would really move the needle, what would you choose, and what would we need to do in order to make that happen? And I'm just curious to know, are there any moonshot or left field type items which could assist in that space? And it's not that it's relevant, but just for example, I know people are talking about 15 years down the line, we've probably got AI actually as our governance, where it'll actually make the decisions that are right for us, not what people want. And so you won't have political parties that are just pandering to people that actually aren't serving the long-term interests of our planet. You're actually having people, we can't fast track that, I don't think. But I'm just curious to know, if someone said, Mark, there's a lot of money, go for it. What are the 3 big ticket items that you'd hit first?
Okay. A couple of preliminary comments. Number one, AI governance telling us what to do, or is it telling us what Elon Musk says that's good for us? And so we need to be very cautious about. Secondly, you said, not much optimism in this domain. I'd challenge that. I actually think that there's plenty to be optimistic about. And amongst other things, that there's studies which show that when people take on board the messages of climate change and adapt to that climate change, they become less stressed and they become more in control of their lives. And that is actually a really positive thing. Even if the net impacts of climate change are negative, taking control of their lives actually is a really, really positive thing. In terms of the things that you could do, well, one would be in Australia, putting an appropriate price on greenhouse gas emissions, so a whole of economy system. At the moment, we've got a very partial system, the safeguard mechanism. That would be starters. If, because we're talking about the built environment today, I'd actually say that moving very quickly to very low emission construction methods, and either being pretty much emission neutral during operation or emission positive in the sense of you're generating more electricity than you're using, is actually quite feasible. So we have the technologies to do that right now. And the built environment is such a big part of our emissions profile. We need to do that. So the idea of building 1.2 million new houses in Australia, but building them in the old way, which is really expensive in emissions during construction and really expensive in emissions during operation, makes no sense. We need to be accelerating change within our building industries, right from where to go at the moment. And lastly, and I did see something from Peter Newman on this, renewables are a great story, is that it's, various assessments saying this is the cheapest energy in the history of humankind. We need to be thinking smartly about how do we maximize the benefit from that.
Mhm.